Okay, folks, it's gonna be loud on this video because it is thundering like crazy, and I've got a freaked out dog trying to make his way into my lap while I try to do these. So we'll see how this goes. So this is what we talked about yesterday. We kind of briefly went over this idea. So, sorry, there are all kinds of noises happening right now. But we didn't really get a chance to work through these, so I kind of want to talk about how you would explain why the limit does not exist on each of these and what kinds of things that we are looking for here. So again, we mentioned that if a limit shows different left and right behavior, then the limit is not going to exist. Now, we are looking at, for this one, the limit as x approaches 0 of the absolute value of x divided by x. And so what we want to look at is we want to look at a table of values coming from the left and coming from the right. So, whoops, I'm on a highlighter. Let's see. I have not used this thing since last May. Okay, so we have our x and our y, and we're going to set this up. So now I'm going to come at it from the negative side, negative 0.1, negative 0.01, negative 0.001. So those numbers are getting smaller. Those are getting closer to 0, which our value for 0 is going to be undefined, obviously, but we're going to work through it so we can see where we're approaching. And then the next step will be positive 0.001, positive 0.01, and positive 0.1. I don't know why I put zeros on that one and not on the other side, but you get it. It means the same thing either way. So this side, we are coming at 0 from the left. This way, we are coming at 0 from the right. That's what we're going to look at. So if we work through these, the absolute value of negative 0.1 is going to be positive 0.1, but then we divide by a negative, so we're going to get negative 1. We're dividing by itself. So the way this works out is that for each of these, we get negative 1. This is undefined. Holy cow, I don't know if you guys can hear that thunder on the video. This is intense. And then you're going to get positive 1, positive 1, positive 1 when you evaluate those. So when we come at it from the left, that is to say that on this side, the limit as x approaches 0 from the negative side, I wish you could see my dog, Marty, stop, of this function is going to be negative 1. But if I approach it from the other direction, the limit as x approaches 0 from the positive side is going to be positive 1. So that is how we can show that the limit does not exist. Now, if we were going to explain why the limit does not exist, then you would want to say something like this. Since when x approaches from the left, we obtain a different value than when x approaches from the right, the limit does not exist. That is how we would be able to explain why the limit does not exist. And so in this case, that is what you would want to say. Now, this one just says show that the limit does not exist. So I think that showing, if you were to show the two reasons here and here, the two-sided limits, and if you just wrote something like negative 1 does not equal positive 1, therefore the limit does not exist, that would be fine. On the following two problems, it says discuss the existence of a limit. Anytime you see that word discuss, I'm going to expect to see sentences in your response. That's asking you to describe and justify. So if you see discuss, that is a writing question, and I'm going to expect you to be writing, okay? A sentence or two just explaining what you know about the limit and what conclusions you can draw. So if we are going to look at this one, we want to do the exact same thing. So we'll create a table. And again, I just want you to notice that the table is symmetric, like on either side of 0. Sometimes we might do that out of order, and you're going to get confused as to which way you're going, like to approach 0. Okay, now my lights are flickering, so I may lose power here sooner than later. Hopefully not. Okay, so then we'll go through and evaluate that. So 1 divided by x squared, these are the values that we get. Here's what we get. So as I approach 0 from this direction, you can see my numbers are getting increasingly larger, 100, 10,000, a million. Same thing as I go this direction. So they're both getting ridiculously large very, very quickly as I approach 0. Now, there's two different ways that you could put this. What you may not write here, and I don't know what Mr. Kaiser showed you guys, what you may not write, so this is not okay. You cannot say that the limit as x approaches 0 of 1 over x squared equals infinity, okay? And this was something that my AP trainer this summer really stressed to me. You cannot equal infinity. Infinity is unachievable. This is the problem with this statement right here, okay? Infinity is not a specific value. That is why you cannot say equals. So what you can say is you can say that the limit as x approaches 0 of 1 over x squared tends towards infinity. But I think the easier answer here would be to say that the limit as x approaches 0 of 1 over x squared does not exist since the function does not approach a specific value from either side. That is how you would want to explain this. And again, because this says discuss, you're going to want to have at least one complete sentence there. I know in class you guys ask me which one I would prefer. I will accept either one. However, I believe that the second one, saying that it does not exist, is a better answer. So it's more specific, and it really kind of gets to what is going on in this problem. So that would probably be the direction I steer you towards, even though that might be a little bit different than what you've learned. But what you really, really, really have to take away from this is the limit does not equal infinity. A limit cannot equal infinity. It tends towards infinity. You're getting closer and closer to infinity, but infinity is not a number that is achievable. Infinity is an idea. So that is something that you want to think about. And then the last one, when we looked at in class the oscillating behavior, I showed you the graph here. And so this function, when we make our table here, we want to be a little bit strategic because you can plug in 0.1, like that. It's a little bit harder to see what's going on because when we're talking about our trig functions, it's a lot easier sometimes to measure in radians. So things that are going to be easy to do are going to be like sine of pi halves, sine of pi thirds, things like that. So think about this situation. 1 over x means the reciprocal of x. So if I want to do the sine of pi halves, then what I really need to plug in is 2 over pi. Hopefully that kind of makes sense to you. The reciprocal of 2 over pi would be pi over 2. That is something I can evaluate in my head. So I'm going to create the following table here. Once again, the reason I picked the values I did, 2 over pi, because the reciprocal of that is pi over 2. 2 over 3 pi, the reciprocal of that is 3 pi over 2. So especially with our trig function, sometimes you want to be a little bit strategic in what you choose to plug in. Now, the reason that I'm just doing those is that is really going to approach 0 from either side. Because with our sine function, remember, we're coming from the left and from the right. We know what sine looks like, but also if you think about on your unit circle, you can either go clockwise or counterclockwise. But either direction, you're going to be approaching 0. Because you're going to come back to it. Not only that, but 3 pi halves is equivalent to negative pi halves. So if you came at it from the other side, it would be similar. But really the idea here is we just need to see what's going on. So the sine of pi halves is going to be positive 1. The sine of 3 pi halves is going to be negative 1. But the sine of 5 pi halves is going to be positive 1. The sine of 7 pi halves is going to be negative 1. So you can see that this function is bouncing back and forth, can't make up its mind of what it wants to do. Positive 1, negative 1, positive 1, negative 1. And so when we discuss the limit here, we would say that the limit as x approaches 0 of sine of 1 over x does not exist because And the easiest way to say this would be to say that, oh shoot, oh, it went away. I'm going to rewrite it. Hold on just a second. So what you would want to say is that the limit as x approaches 0 of the sine of 1 over x does not exist because the function f of x equals sine of 1 over x exhibits oscillating behavior. And I believe that that is going to be enough to be able to state why the limit does not exist in this case. It never approaches one value. As soon as it gets close to 1, it starts heading back towards the other one. And so that's the case. So there's that. That is the first little bit about limits. Just remember those powers of 10. Tenths, hundredths, thousandths, 10, 100, 1,000 that you want to plug in. That's the biggest thing here, okay?